Welcome to week 11 of the History of Industrial Design. This may be a little bit more of a mess than normal because this is a sprawling amount of information. And in class, delivered all at once, I can create a narrative arc that makes a certain amount of sense. But in an effort to break it into 3 smaller bits for you, I'm worried that the storyline will just fall apart. Let's see what happens. The videos on the screen are usually playing before class, and the one on the top is really instructive in helping understand injection molding and how that process works, and also the pretty remarkable technical accomplishment that creating this chair represents. And on the bottom are 2 television ads from the 70s that I just think are important for designers to have seen. On the left is Woodsy the Owl, which taught every child of the early 70s the importance of cleaning up after themselves, but did so with a really catchy song. So I recommend watching that on YouTube and learning the song. And the one on the right was made by Keep America Beautiful in 1971, and I would bet that it's the most remembered television ad ever created. In today's world, we consider entertainment and education as separate things. In the early 70s, one of the great things about television was it found a way to educate our children while entertaining them. And these ads are both great examples of that in action. As a child of the early 70s, I learned grammar from television. I learned etiquette from television. I learned respect. I learned how to tell a story. I learned how to clean up after myself. And now we just abandon our children to TikTok. So one of the reasons I start class with these videos is to help students of today realize the power that that kind of combination can have, because I think we should bring it back into our world. Okay, let's dive in. Over the last couple of weeks, we looked at mid-century form and manufacturing confidence by tracing the development of plywood, and then continued that investigation by looking at design with other materials, examining housewares and new ideas about the home, but also looking at design for corporate environments. And for the first time since the Industrial Revolution, we seem to have the ability in that era to manufacture things in volume while also controlling the aesthetics. And we arrived at a confident expression of form as decoration instead of decorated forms. So you'd think it's all figured out and done, like the Industrial Revolution gave us this difficult challenge, how to make things in repeat, use the machine. It took us till the 1940s to figure it out, and then after the war, we charged forward making amazing things. But the reality is the pendulum always swings, and whenever we get something figured out, there's always a new curveball thrown at us. Plastics arrived and gave us a really difficult challenge. Unlike plywood, which looked at the material limitations of thin layers of wood and used those limitations to arrive at form, plastic could take any form possible. So you could introduce some ergonomic considerations. There are some limitations in mold size, which is sort of a material constraint, especially in the early days of plastic. But otherwise, none of our friendly old limitations apply. And design is more difficult when there are fewer limitations. So plastic was a real blessing because we could begin doing new things that we hadn't been able to do before, but it was also a real curse. We're going to look this week at all of the struggles to overcome this new material. Remember that plastic offers some really interesting construction opportunities. These are the insides of 2 remotes, a television remote, I think, and a gaming remote, I think. This old man don't use either. You can see in these moldings that plastic allows variable wall thickness, and you can have strength where you need it by introducing ribs or extra material, which you can't do in sheet metal. And you can introduce connection points, so you can have bosses that receive a screw. Plastic also allows connection tools. You can have a snap fit, so built right into the parts or the mechanical connectors that will join them. Plastic also allows variable connection surfaces. You can build a shoulder in for glue or a tape. You can also mold right into the part numbers and assembly instructions. On the part on the top, you can see color coding and information for assembly. All of that ends up hidden on the outside. With plastic, you can have a controlled, smooth form on the outside. You can have multiple textures in one material, and you can hide all of the activity and complexity on the inside. So keep that in mind as we're looking at all these objects, because you're only going to see the outsides of these, and there's a whole crazy hidden activity on the inside. I want to dial it back for a moment to give us a foundation for this discussion, and also to include some things you should know about. The Ulm School has a really long German name, and since I'm recording this and posting it publicly, I'm not even going to try it, but we all just call it the Ulm School. It was established by Inga Eicher-Stoll and Adel Eicher in memory of Scholl's brother and sister who had been killed by the Nazis. And the school was imagined to be devoted to politics and philosophy and culture in a really intentional effort to help the moral rebuilding of Germany. The Bauhaus had been closed by the Nazis in 1933, and after the war, there was a strong desire to send Germany in the right direction, a better direction, a different direction, intentionally through education. The school only existed from 1955 to 1968, so it wasn't long-lived, but it was incredibly influential. The school had 5 departments: visual communication, industrialized building, information, filmmaking, and product design. In all of those departments, you can see, even just in their names, that industry is part of the program. It's not in spite of the program. We'll not add industry because we have to. Industry is woven into all the thinking about what this education would be useful for. The building was designed by Max Bill, a former Bauhaus student. And there are just a couple of other things of Max Bill's I'd like to show you. In addition to designing the buildings, Bill worked to help design what we call the Ulm stool, the Ulmer Hocker, in 1954. The stool is a beautiful example of designing for circumstance. It's made out of fir boards that were donated to the school and broom handles. And the design was not meant to try and hide that, it was meant to celebrate that. One of the frustrations with an object becoming iconic and important, and as a result scarce, is that it generally gets reproduced and the original intent is destroyed. Zanoto makes a copy of the stool now, but out of plywood, and sells it for $500. So what started out being scrap wood, utilitarian, humble, fast solution to a problem is now a fetish. In addition to designing the building and the stool, Max Bill also designed products. He's known as one of the fathers of the Swiss style of graphic design, and if this were a graphic design history class, we'd look at more of his work. If you are ever going to design a clock face, go back and look at his. They are remarkable in their simplicity and equally remarkable in their complexity, which is a difficult thing to balance. That Max Bill was part of the development of the Ulm is significant because he came from the Bauhaus. And the Ulm school was trying to intentionally take some of the thinking at the Bauhaus about industry and design and how they could fit together and actually make it happen. I also want to point out the clock on the right, which is Max Bill's update of an existing type of clock, a kitchen clock, a wall clock with a built-in timer. He brought it into the 1950s in a really beautiful and elegant way. And one of the tragedies of living when we do is that this still exists as an object that is made. You can buy a knockoff version of this now. So here's what Max Bill's work has turned into in our world. I hope you see the difference. I hope you understand how much is lost in this translation. And I think it will also help you really appreciate Max Bill's abilities. This is a great example of the difference between simple and simplistic. Something that's simple can still be elegant and sophisticated. The clock on the right is simple. Something that's simplistic is lacking and tragically flawed and underinformed and underdeveloped. The clock on the left is simplistic. Anyway, the faculty at the Ulm School included a lot of names we already know. Joseph Albers, Johannes Itten, both former Bauhaus instructors, Hans Gujlo, whom we'll look at today, Adel Eicher, and then visiting lecturers came from all over the world to participate in this exciting new school. Mies van der Rohe, Walter Gropius, Charles and Ray Eames, Buckminster Fuller. And the product design department at the Ulm School radically changed industrial design practice. Manufacturing advances in World War II had forced designers to include manufacturing in all their thinking. The emphasis at Ulm on science and technology and industrial production led to a new kind of rational design, less purely geometric than the Bauhaus, and way more manufacturable. This is a good example. The TC100 was designed by Hans Rohrig in 1959 as part of his thesis project at Ulm, so get busy, students. It went immediately into the permanent collection of the MoMA and went into production in 1962 and stayed in production until 2006. People always throw out like it went into the collection of the MoMA as if that's a real accomplishment. For me, there's an even bigger accomplishment that the TC100 achieved, which is that it went into use in the cafeteria at the MoMA. Because this wasn't just something pretty to live on a shelf. It was durable, stackable, dishwasherable, functional, and contemporary. I think these ceramics have a really beautiful balance of rationality of the Bauhaus with organic form of Russell Wright and Eva Zeisel, but with a new layer of increased functionality. If you're interested in design education, checking out the product design curriculum at the Ulm School would be worth your while. Max Braun was a mechanical engineer near Frankfurt in Germany, and he began producing radio components in 1923, right at the beginning of production radios. He started making complete sets in 1929, and he quickly became one of Germany's leading radio manufacturers, known from 1932 on for the Combi unit, the combined radio and record player. Max Braun also used plastics really early on. He used homemade presses to mold plastic pellets all the way back in 1925. During the war, the factories were essentially destroyed, and Max had to rebuild the company completely. These are early products sold by Braun. You can see that they're modern, they're smooth surfaces, they have rounded corners, but they're not really pushing the envelope much in terms of design. Max died suddenly in 1951, leaving the company to his two young sons, Arthur and Erwin, who took over. And they realized that there should be design involved in a way that it wasn't. Erwin went to hear a lecture by Wilhelm Wagenfeld, remember him all the way back in the Bauhaus time? And hired him to help make that happen at Braun. Wagenfeld did a pretty amazing job bringing Braun design into a new era, but the designs are still a little bit clumsy. Nevertheless, a lot of the Braun DNA is visible in this. There's a bold two-color approach. There's a mixture of plastics and metal to create overall unified forms. There's an exploration of how to incorporate dials and buttons. These are all foundations for what became the Braun style. At Ulm, there were something called development groups that were formed to allow students to work with industry, to put their designs into production. And this is different from what happened at the Bauhaus. The Bauhaus was creating designs and then trying to get them produced by industry. The Ulm School was designing with industry to create things that were producible. There were really successful projects with Braun, with Lufthansa, with Railroad Hamburg. We're going to look at the Braun projects now. These are examples of some of the earliest products designed as a result of that development group. And they're really different from the earlier Braun radios. They're still wood, but they're using wood in a much more modern, sort of mid-century way. It's worth mentioning that we usually see pictures of these objects independent, but they were designed to stack. These are radios from the 1940s, some by named designers, some by unknown designers. Some of them are plastic, trying to be wood. Some of them are wood, trying to look like plastic. It's a whole mishmash of different ideas about radios. My notes for this slide just say 1940s radio equals whatevs. And here's the 1950s. Totally different aesthetic, but not really a different goal. It's still plastic trying to do something. Maybe there's some metal, but probably it's actually metal-coated plastic. If you compare that to what Braun is doing in the 50s, it's a very different equation. You may think this is much better. You don't have to. We're going to go all over the place in today's lecture, so don't worry if you don't like the thing I'm showing you. There's something else coming. The Braun style, and what we also now call the Ulm style, became fully developed in these early collaborations. These designs are rational, they're ordered, they're reserved. If you're ever designing something with dials or buttons or knobs, go look at this early Braun stuff, because there's so much to learn from the subtle decisions about arrangement and scale and location. Also, FYI, I have 1,000 FYIs this week, sorry. FYI, you adjust the station on this radio by putting your finger on the round dial and rotating the dial. Does that remind you of anything? There are lots of products that we've looked at a few times this semester, and I hope you've noticed a subtle sort of emerging from chaos that happened with designed objects. They start out as mechanisms or machines, and no one cares what they look like. They get features added. Once what they do gets figured out, the form can then sort of follow along. The kitchen stand mixer is a great example. The one in the middle is really useful. You can tip the motor forward and backward, so you could have a meat grinder in its backwards position, and you could have a mixer in its forward position, and it looks terrible in every position because it's essentially just an undisguised motor. Then on the right, with the sunbeam, you start to get a housing, and the attachments are considered as part of the form. It's very difficult to design an object that has multiple positions. And I should explain the ad at the top, which is for a polishing pad you could put on your kitchen stand mixer in 1950, because small motors were still really scarce, and anybody who had a stand mixer might be looking for other things that small motor could do in their household. So multiple functions were possible with these kitchen stand mixers, but they weren't really fully investigated or realized, and they certainly weren't reflected in the shapes of the objects. This is what Braun did with that same equation. They realized that that interchangeability might be an interesting feature to claim, but it's still a pretty clumsy affair. This is before the Ohm school got involved. So at least they're thinking about unifying the object. The red part is the motor, the other parts are swappable to make it do different things for you. And it seems like each of those objects has been considered as an overall form. But when the Ohm gets involved, it's a completely different approach. The equation is sort of like Braun plus Ohm equals a new era of rational product design. They began conquering putting the motor on the inside and letting a form expression happen on the outside, also examining where the buttons and knobs went and how they told you how to operate this object. The outside has no hint of any of the interior complexities that are happening. The pictures on the bottom show the kitchen machine in 3 different uses, and I think you can see the forms are considered in each of them. There is a rigid geometric logic in evidence in this machine, but not at the expense of the beautiful form. There's geometry involved, but it still manages to seem somehow organic. Whenever I find an object interesting looking or satisfying looking, I try and figure out why. This mixer offers some really interesting information if you examine it with an overlay. This is a golden mean rectangle, and I located all of the major dividing lines and angles of the kitchen machine. And you can see there's really careful thought. The angle of the bowl is repeated on the outside angle of the mixer. The dividing lines break the rectangle down in even considered parts. And even the location of the release button at the top, the center of the Braun logo, and the knob at the bottom have been lined up with intent. Another product that has the same narrative as the kitchen machine is the shaver. Braun plus Ohm led to really subtle but dramatic transformations in the shavers. The Braun brothers did an okay job on their own. They gave the shavers texture so they'd stay in your hand nicely. They put a logo on in a contrasting color so you could see it. They combined plastic with metal with some authority. But when you add the Ohm equation, the parts get unified in a really masterful way. The Ohm project also looked at creating a standardized aesthetic across different products at Braun, which is kind of a new idea in manufacturing. The logo became bigger and more prominent. There's a controlled color palette. All the subtle details seem to disappear into the background. At the same time, they become so important to the success of these designs. And where that formula worked, it produced gorgeous, restrained designs. There's an authority to the material use in these shavers that the world had really not managed before this. Combining plastic with metal, with different kinds of metal, with cast metal and sheet metal, different colors of metal, creating objects that could house ever smaller motors was all done with tremendous success. By 1960, Braun shavers were so successful that they established the standard for this product type, and all other shavers started to resemble these. In 1954, Ronson in the United States paid Braun $10 million to license their shavers and distribute them in the United States. That's $88 million today. This was a really successful design project. And that mixing materials with confidence can be seen in a number of early Braun designs. There's at once a rigid geometry without the objects seeming overwhelmingly geometric. They're rational, but I think they're still full of a sort of subtle, quiet, but funny personality. This is a desk fan. The motor is housed on the right. It has 2 speeds, and the cylinder on the left spins and produces a breeze. The acrylic shield can be angled so you can direct that breeze where you want to. Braun also identified all sorts of products that the world needed but didn't know it needed yet. Film cameras, film projectors, slide projectors, stereo equipment, in a dizzying array of combinations and features. In the same way that the Eameses looked at airports and dorms and found new environments for their furniture, Braun looked for new products and new environments to apply their design success to. I showed these images the first day of class in my desperate effort to inspire students to do primary source research and to expand their thinking about what a primary source would be. I showed the picture on the upper left, which is from eBay, to help explain that seeing the insides of something allows you to see the design solutions being applied and tease out what the problems were. This is one piece of bent sheet metal that's been really smartly stamped and bended to then receive the electronic components and create a smooth, unified exterior. And then we also looked at the picture on the bottom, which is a Braun promotional image, which is making a lot of subtle but really loud statements. Like this record player is as beautiful as a piece of fine art, so don't hide it, leave it right out in plain sight on your bookshelf. Braun was asking the world to reconsider what a stereo could be. If it's going to sit out, it should be attractive. This is just 1 year later than the wooden turntable and radio we looked at a few slides ago. So they're making progress really quickly. Even after the Ulm School closed down, the effects were really long-lasting. Because of the success of the Braun and Ulm partnership, and because of the success of the Braun products, around the world, designers and design directors started talking about Ulming stuff up. If you did a design and you showed it to the marketing department, they'd say, could you Ulm it up a little? And everyone knew what that meant. Could you round the corners just the right way? Could you make it out of a smooth, colored plastic? That's one of the dangers of success. You become a style. Braun arrived at a really remarkable consistency across products and across time. There's no reason a coffee grinder, a table lighter, a hairdryer, and an immersion blender should have any overlapping DNA. They're completely different products, they're used differently, they're used in different places, and Braun was able to make each object look the way it needed to look because it worked successfully, but also share in a kind of family resemblance across all the product lines and over decades. You may have noticed that Dieter Rams' name has appeared on many of these slides, so we need to look at him a little bit more. Rams started at Braun in 1955 and became design director there in 1961, and then retired in 1995. That's over 30 years steering this company's design direction, which is one of the reasons they were able to arrive at such consistency. Rams wrote, "Good design for us means as little design as possible. Not for reasons of economy or convenience. It is surely one of the most difficult tasks to arrive at a really convincing, harmonious form by employing simple means. More complicated, unnecessary forms are nothing more than the designer's escapades, which have the function of self-expression instead of expressing product functions. The economy of Braun design is a rejection of this type of design. It leaves away everything superfluous to emphasize that which is more important." Dieter Rams also wrote, "The aesthetic requirement of an industrial product is that it should be simple, carefully made, balanced, and unobtrusive." You don't have to agree with this. You could decide that for you, design needs to be badly made and unbalanced and really obtrusive. But right now we're living in the land of German rational design, so stick with me. In a Dieter Rams design, the details make the design. If you need to design something with really careful detailing, go look at this work. If you need a good bevel, if you need knobs, if you need an interface that is carefully controlled, that disappears into the background so that people just understand it, go look at this work. I have another clumsy geometric overlay to show you that this is not a golden mean rectangle. This is a rectangle made of two squares, which has a name in geometry, but I'm not a geometrician. Geometrist? What do you call someone who does geometry? Anyway, it's two squares. The venting on the left allows the sound out. If you just milled all the slots in the aluminum, you'd have flexible slats. So there's a connecting spine down the middle, and that cuts the circle right in half, and also is the central dividing line in that square. And then a really interesting thing is happening in the square on the right, which is that the diagonal identifies the two most important buttons. If I asked you to go turn this radio on, you would know that the lower right-hand button and the upper left-hand button are the two most important ones. And that's not an accident. Here's evidence of how Dieter Rams took the Braun and Ulm transformation even farther. This is a great series of redesigns. On the left is the Braun juicer before Ulm. So just like the kitchen mixer, it's got red for the motor, it's got an ivory color for the top. It kind of makes some sense, but it's got some room to grow. Gerd Alfred Müller and Robert Oberheim's mixer in the middle is done as part of the Ulm project, and you can see it's way more rational, it's way more considered. And then Jürgen Gröbel on the right shows the maturing of the Braun aesthetic into something that's really a beautiful unified shape. That one tiny little orange dot so clearly says, put your glass here and I'll give you some orange juice. That's the only color on it. It's a little unfair to combine Dieter Rams' mixer with those because those are large multi-mixers. This is a smaller device made just for citrus. Nevertheless, I think it shows his ability to create something that is at once intensely sculptural while also being unified and quiet and refined. If I had endless time and endless patience, I would do an overlay on this object too, because the repeat of the radius is the triumph for this object. Instead, let's go off-roading and look at transistors. One of the challenges in doing this class remotely is that in class we have 5 student presentations a week, bringing information in that matters to this narrative, and now we don't have that. So I'm trying to throw just enough in that I don't derail those, if they still happen, but I can still maintain a complete narrative here. Braun's success is really evident when we compare it to similar efforts being made by other people at the same time. We have to look at transistors because they changed everything. A transistor is a transfer resistor. It replaced bulky and temperamental vacuum tubes and allowed the miniaturization of electronics. The first transistors were made at Bell Labs in New Jersey in 1947, and the first silicon transistor was produced by Texas Instruments in 1954. A transistor functions as a switch or a control, on-off, but it also works as an amplifier. Transistors are now incorporated into integrated circuits, and we'll look at that a little bit more next week. One of the founders of Sony, Masaru Ibuka, was on a sales trip to the United States in 1952, and he saw a demonstration of the transistor and decided that he would license the manufacture of transistors from Bell Laboratories so that his engineers could figure out what to do with them and what they could be used for. If you're interested in the history of the transistor, a book called The Idea Factory investigates the history of Bell Labs and tells the story of transistors beautifully. The Bell Laboratory method of working was to just figure stuff out and then work backwards towards solution. That's the way a lot of engineering happens. They figured out the transistor and they demonstrated it to as many people as possible, hoping that the world would figure out new uses and they could monetize their invention. Sony was a big part of that monetization. And one of the things that Ibuka was determined to do at Sony was make things that were affordable. He realized that if they were going to produce transistors, they had to produce objects that everyone could afford to make the investment worthwhile. And that distinguishes their work from Braun. Braun products were always expensive. On the left is Sony's first transistor radio, which came out in 1955, but I'm more interested in the pocket radio from 1957 on the right. And there's a great story about this. It was called a pocket radio because it was so small, but it wasn't quite small enough to fit in a pocket. So Sony removed the pockets from their salesmen's shirts and put on slightly larger pockets for demonstration purposes. Nevertheless, it was a remarkable accomplishment to be able to squeeze into a tiny handheld device all of the equipment that used to take up a huge suitcase-sized object on a shelf. And it's important to remember that this transistor technology was really, really new. In 1955, it is very easy to screw up new technologies. Compare these two. There's nothing wrong with the Sony transistor pocket radio on the left. It's kind of fun. It's red, it's playful, it has a big round speaker, it has a flip-out stand, but it also has knobs sticking out on every side, so if you go anywhere near it, you're going to turn it off, change the volume, change the tuning. It's not really all that considered. It's merely produced. The Braun radio on the right is far more sophisticated in taking on the interface and the relationship between the interface and the object. And they both cost about the same. The Sony was $50 and the Braun radio was $58. That's about $500 today. The pocket radio was also designed to have an add-on component. You could attach it to the record player and it functioned as the speaker for the record player. I'm really intrigued by this record player, one, because look at the beautiful symphony of squares and rectangles and circles, and the subtle relationship of those details in this object. But two, when you put the record on and pressed play, a door opened and a needle came up from below and played the underside of the record, which to me just seems confusing and wonderful. Dieter Rams is well known for his 10 principles of good design. Many of you who have encountered these so many times that you're rolling your eyes, but they're not in the Industrial Design Reader, one of the textbooks for this class, so it's worth going through them now. Good design is innovative. Good design makes a product useful. Good design is aesthetic. Good design makes a product understandable. Good design is unobtrusive. Good design is honest. Good design is long-lasting. Good design is thorough down to the last detail. Good design is environmentally friendly. And good design is as little design as possible. Again, you can disagree with all of these if you want to. I wanted you to see them because for me, another important part of this is the long-lastingness and the environmental friendliness of this. That's going to be a big part of what we're going to look at in the rest of this lecture. We have not used plastic for long-lasting objects. We have used it for short-term objects, and that's led to an environmental disaster. If you design things that last a long time, they will earn the amount of plastic that you use for them. So you'll be creating things that are inherently better environmentally. And that's an idea that isn't new, but it's still something we're struggling to incorporate into our realities. A number of years ago, there were a bunch of blogs that showed how Apple design, especially Jonathan Ive, was ripping off Braun designs, especially Dieter Rams. And people were outraged and saying that Apple was fraudulent and Ives was a plagiarist. And I just thought, that's the whole point of history. I mean, that's the whole point. If someone did something well, you should learn from it. And the designs are not plagiarizing because they're making completely different devices. The calculator as an interface on the phone gives you calculator function, but the phone was not a calculator. It did much more than that. The iMac is not a loudspeaker, but it is a large electronic rectangle that needs to be stable and cantilevered. And although the iPod and the T3 radio do both produce music, and they have an interface where you want sequential choices so a dial works, there's not a lot of other overlap. So I actually think this is proof that Jonathan Ive is a brilliant designer because he's using history and success as inspiration and fuel for the future. So that was the story of Braun and their design success, which coincides with the introduction of plastic. And if we just looked at their work, you would think that incorporating plastic was no big deal. In fact, it was quite difficult. So the next chapter is going to look at other designs in plastic and the history of how plastic was used in objects. And this class isn't normally about manufacturing techniques, but without understanding some of the basics of plastic manufacturing, the objects we're going to look at don't make a lot of sense. So I just want to talk through these videos as quickly as possible. Rotational molding puts liquid plastic in a mold that's heated and rotated, and that allows the liquid plastic to flow over the surface as it hardens. Usually this is PVC with a plasticizer in it, so that molded object is still flexible, and you can pull it out of the mold. There are larger objects that are made with rotational molding, and they need multiple part molds and a much larger rotating device. Extrusion blow molding takes liquid plastic and forces it out of a die that makes it into a tube. That tube is then placed inside a mold, which is closed around it, while air is pumped into the tube to force the plastic out against the mold. You can always tell something that's been blow molded because it will have a seam all the way around the outside, and there's a cutoff at the bottom where there's sort of a ragged edge. It's not a very neat process. It tends to be used for things like shampoo bottles, milk jugs. Injection molding is probably the most common. And I'm showing you a really fancy version, which is injection co-molding. It's a series of highly sophisticated, carefully matched, computer-produced molds. This is toothbrush molding. So the first mold has liquid plastic squirted in, and that makes the main body of the toothbrush. Then the mold is opened and rotated, and a new half is added to the outside, and a secondary plastic is put in. That makes the soft, grippy part of the toothbrush. So this is two different kinds of plastic and different colors of plastic molded into one object by having sequential molds. And all of these videos are in the YouTube channel playlist if you want to watch more of them. So that's part one, and I'm going to stop and let you take a break. Come back for part two, where we'll look at the development of plastic and how we started to use it in utilitarian objects. So Nota makes a copy of this stool. Oh man, this slide sucks. Should I just start the whole lecture over? It's going to take me so long to patch this together because I'm doing such a bad job. Just leave that crap off. No, don't even apologize. Don't apologize. Just do it. And these are examples of the earliest of... my shirt is sticking into my neck. My cheap shirt from Target is scratching. Hey, I'm sorry if it's really loud in the background. It's a really nice day out for the first time in ages, and everyone with a motorcycle is trying to remind me of that. The pictures, here's the thing I do. I have a train wreck of a sentence, and then I just start it over. But I never stop to think about how will that sentence end. And then 7 times later, I still haven't ended the stupid sentence. Take a break while the sirens go. Are you noticing more sirens than ever? Is it because I'm hyper aware, or is it because there are more sirens? I don't know.